Okay, let us see what happens if we have this question. Still, it's about resolving forces. Now here I'm going to see the particle. This particle is going to be having a certain mass, and then they are telling us that find the resultant force of the particle, then the acceleration of the particle. So where do we go? So the question is, a particle mass 10 kilograms, is that there are some forces acting upon it. This is purely horizontal, purely vertical. Then we have these ones, which you need to resolve. Now we say, the moment you start, you have more than, you have many forces, it's easy to get a single force so that you can easily get this resultant. So to get the single force, you need to get the x component, or the components, x components of all these forces, their total, and also you get the total of all y components of these forces. So why do we do this? We do this by resolving. So this one is okay because it's purely horizontal, purely vertical, and then these ones, they are the ones we are going to resolve. So now here, you be careful. Instead, the angles here are upon you. Always be careful with the angle. So instead, our angle here is from the vertical. So meaning, if I'm to resolve this, I need to go this side, then like this. So this one, if I start to resolve this, I will go this side. Then after, I'll come this side like this. So this will be now our 90 degrees. You start first to go like this, so I move like this, then I come like this. Now this is the angle. Now this angle, this side here is adjacent. So meaning, to resolve this, we get 3 root 2. Because it's adjacent, then we use cos. Then the angle, which is 45 degrees. Now this one is opposite to this. We said opposite, we use sine. So you get the force 3 root 2, then sine of the angle, which is 45 degrees. Okay, so we have finished resolving this. Then you come to this. You start now the angles here, so you're going to go like this, then come down like that. So we said resolve them into perpendicular components. So we are going to go like this because our force is going this side, then we come like this. Based on this angle, this is adjacent. So start this one will be now the force, which is 8. Adjacent, we say adjacent goes with cos. So then cos of the angle. So now this angle, this side is opposite, so we shall get the force, which is 8. Then sine of that angle, 60 degrees. Okay, so we have finished also resolving this. Then we come to this. It's the angles here, so we shall go like this, then come back like this. So I go like this, then I come this side. You see the side is adjacent, so we shall get the force, which is 10. Then this is adjacent, so cos 60 degrees. Then this one is its opposite, so we shall get the force, then sine of 60 degrees. So whenever I see the idea we're using is so toward. A side adjacent goes with cos, a side opposite goes with sine. So from there, now we have finished resolving these two non-vertical and non-horizontal forces. Then you can get now the x component. So the x component, now resolve them to this side horizontally. These are the forces which are horizontal. So we start with these ones which are going in that side, in this direction. So with the ones which are not opposing. So first we have the 12 newtons. I have the 12, then plus. Any force which is going this side, is that also this one is going this side. So plus 8 cos 60 degrees. Are those the only forces that are going this side? Okay, if those are the forces, then we come to this one going to this side. So we say if the main one side is opposing, so this one is opposing, so we should say then plus, whenever it's opposing, we put a minus. We have 10 sine 60 degrees, then plus. Is there anything which is opposing? Yes, I'm seeing that there is this one. It's going, this side is also opposing. Then minus 3 root 2 sine, sorry. Okay, sine 45 degrees. Okay, whenever the forces are in the particle, you be careful. They're going to Okay, then what else is that we have this one? They said this one is probably vertical, so meaning the horizontal force there is going to be 0. Then when you get our value, you press that on the calculator. So you have 12 plus the answer I'm getting here is 4.3397. You give 4 decimal places. Okay, now let us resolve vertically. So vertically we shall be getting our y component. So we start with this one which are going in that direction. First of all, we have this one, the 5 newtons, then plus those which are going up. We have this one, which is 3 root 2 cos 45. Is there anything that is going in that direction? We have this, we have that. The rest are opposing. So start now, this one is opposing, and this one is also opposing. So there we shall attach negative, so plus, minus, this one is opposing, 10 cos 60 degrees, then plus, and minus, even this one is opposing, which will be 8 sine 60 degrees. So whenever the angles are from the horizontal, it's very easy, but whenever the angles are in the vertical, you be careful when you're resolving. So there, our y is going to be, still replace that on our calculator. We have 5 plus here I'm getting negative 3.9282 newtons. So from there, these are now my resultant force. The x component, we said is given by x, y, which will be our x, which is 4.3397. Let it come to our y, which is negative 3.9282. Then when we have that, then you can easily get our resultant. So if you have sketched that, you can see you have a positive, then you have a negative downwards there. So sketch it, you can see this is what we're going to be with. The one which is going downwards there, our resultant is going to be that force. It's going this side, then comes that side. So this is our resultant, the FR. So if you get a magnitude, so this one is going to be 4.3397. Then this one is 3. The direction, if you want, you can put a negative, but this one already shows that it's going in the negative direction. So our resultant there, our FR, is going to be the square root of, we square this, 4.3397 square, then plus, of course, this one is going to be negative 3.9282 square. So which will be, you give your answer for the decimal places. So here we have 5.8535 newtons. So for decimal places. Then the direction, our direction, this is going to be our direction, let's call it theta. So it's going to be, our theta we say, is going to be tan inverse of the opposite, which is 3. You see to this angle is going to be the opposite over that adjacent, which is 4.3397. So our theta there is going to be here we have 42.15 degrees. So then to describe, I think we have seen the description. We said the resultant is 5.85359 acting at 42.515 degrees below the horizontal force. The horizontal force of this is that acting there below the horizontal force. Simple as that. Then the term part B, acceleration of the particle. So you start in this question. They gave us the mass of the particle. Now we have the force. Now, this force here is the one which is going to be accelerating this particle. So that the particle is going to be accelerated like this. Because the force that is going to be accelerating this is cutting in this direction. So this force here is this. So now meaning we have the force, we have the mass, then we need the acceleration. So our force, remember that our force is always equal to mass times the acceleration. So we need that acceleration, which implies that our acceleration will be the force over the mass. The acceleration of the particle. So now this will be our F, will be now the force. We take its modulus, which is 5.8535, the whole over the mass. Our mass, which is 10. So there we can easily get our acceleration as 0.58535 meters per second. So that's going to be our acceleration. So that's how we handle that, members. I wish you well. We are going to now make examples. I think we have seen how we have described, we have got the acceleration with the resultant. Always, the idea is whenever they give you this question, make sure you get a single force because you can easily get its magnitude and you can easily get its direction. So we are going to make examples about now getting those of polygons. See you there. So remember this acceleration is given in meters per second squared.